I'm Dan Salusta. I'm Chief Operator at the Alden Wastewater Treatment Plant. We used to be what they call ELAB certified, but it was cheaper to outsource a lot of our stuff to local labs. Right now we go to area county labs, but some of our stuff we do in-house. And we got to do daily testing for our Speedies permit through the DEC. These are Imhoff cones. Every morning we got to fill these up. This tells us how much solids we have coming in, and this is our effluent, how much solids we got going out, and this is usually less than 0.1. This is our outdated alarm system. You see a lot of alarms have pulled because they keep going off, but this will go over our radio transmitters and it'll alarm us at night if there's a problem at the wastewater treatment plant. This is our electrical room for the front half of the wastewater treatment plant. So a lot of this stuff is outdated and it's over 30 years old. This is our confined space equipment. It's for when we have to enter manholes. We have a multi-gas detector we take in with us, and this is our retrieval equipment. Air blower to blow out to get fresh air into the manholes, and safety packs if we have to go in there and retrieve a person. Safety air packs. This is just the compressor room. I wouldn't do too much in this. We got a leaky roof. These pumps pump from our primary clarifiers to our digesters. They are set on timers to run out throughout the day. These were replaced, I'd say, roughly 4 years ago. And that right there is our grit removal system. Now I'll take you upstairs. This is the stinky part. This is what we call cake. That's what happens when we dewater from the digesters. It gets pumped up over here. It's digested biosolids, and it gets dewatered through our belt filter press. We add a polymer to it to help with the process. Like, these are our primary clarifiers. That's where those sludge pumps, those biosolids pumps, where they're down in that one building, they're down in that one room, the white and blue ones. This is where they pump from, or from these clarifiers right here. That building right there is our emergency generator. That's part of our project to get redone. And the 6 white things in the middle are RBCs, but that is one of the biggest processes that we have that keeps this plant running. These are called our drying beds. We used to have a building over these 2 drying beds over here and use them for our storage. They used to come off our belt filter press. But during the big storm that came down, I like to say that it's eco-friendly, because you don't have to use no energy. You open up a valve, you pull it out, the sun dries it. But that's our primary digester right there. That's where those 2 blue and white pumps pump from. They pump into this digester right here. The sludge will turn over, and when that new sludge comes in, it pushes out the old sludge. The old sludge gets pushed out, comes into the secondary digester, which is behind you. This is what we call a digester building. These are our gas mixers. These are our budgeted item for our project. The pump that's out in the fire is pumping from the secondary digester. It's pumping it up to the press upstairs. This is the grit that was being removed that came up from the red pump upstairs or downstairs that was in that one building. It goes upstairs to another pump. And this takes the grit out of this raw sewage coming in. Sometimes you get lucky and find diamond rings. I'm only kidding. I'll show you the downstairs where everything comes in. This is where our 4 pumps are located. The pipes are scheduled to be redone in the project. So you see, after condensation over the years, it's been popping the paint off. This is what we call a bar rack. It collects the rags that we screen through, trying to grab the stuff that it's not supposed to be flushed. A lot of things that don't need to be flushed. Protolactives, Venom products, flushable wipes that say they're flushable, they're not flushable. They do not break down. They cause problems for us. That's the water coming in. From here on out, it's all gravity. There's no other pumping that you have to lift back up until we have to bring stuff back up to the front of the plant. Downstairs is called the bar rack. This is called a bar screen. The bar rack has an opening about 2 inches. Bar screen has an opening about 1 inch. The water passes through. I call them rags, floaties. Gets stuck on them. It circles through and scrapes off. I like scrape it off and scrape off into a bucket. This is the grit removal. This is where it comes down into the wheelbarrow that was downstairs. The plant was designed to be split off if they wanted to add on to it later on down the road. They put provisions in to add on to either side of the exact same process we have going on now. Primary clarifier. This is where that sludge pump will pump out of on a time basis. This gives us time the settleable solids would settle down, and you'll get like a level of so much solids is in there. It gives you like I think it's 2-hour hold time for the water, for that hold down and drain out and settle down. Everything is after here is left and right is the exact same at the plant, so I'm going to take you through one side. This is a distribution box. From here the water comes down, goes to left or right to our primary clarifiers. From the primary clarifiers comes back into this distribution box. It goes to our RBCs to the left or the right. These are called rotating biological contactors. They have little bugs on here that likes eating the rest of the stuff that doesn't settle out. As we go through the process, the color and the different kind of bugs on the media, this is what we call the media, will change. As it goes through, they dip through the water, get some stuff to eat, come back up, get some air, go back down, eat some more, get some more air when it comes back up. You see these ones look a little more of a different color. And then a third process, you can tell it's a little thicker, way different color. But this is where our nitrification and denitrification happens, is in these processes. Every so often, the stuff that we call fluffs off the RBCs ends up in the secondary clarifiers. As you can see, there's some you can see accumulating on the sides. Every once in a while we gotta go through and clean these out, but these are run on pumps also. All the bugs that die off, they'll settle out in this one, or these two. This is our chlorinating room. As you can smell the chlorine. These are our tanks we hold. We roughly go through 14 and 20 gallons a day adding to the water to help dechlorinate, or to help chlorinate the water to kill off anything left. These are our sand filters. This is our tertiary treatment. Whatever water comes through from the dumps off after the secondary clarifiers come in here and gets filtered through sand and the media, and then goes out to our contact tank, which is outside. We pre-chlorinate before the sand filters to help keep them from gumming up. That's the dirty water coming in, and the clean water going out is out there. Second electrical room. These are our secondary sludge pumps that pump out of our secondary our clarifiers. They pump that whatever settles back up to the front of the plant. The loud thing over there is what's blowing air into the contact tank that's outside to help add dissolved oxygen into the water so we don't kill the fish. And this is where that blower comes in and blows the oxygen in, or the air, not oxygen. To aerate the water. Still have some dirt on it from last time. That's the water going out that is clean.
I'm Margaret Tan from Wax News, and we got a chance to speak with Mayor Mike Maneki about the Alden wastewater plant upgrade.
I'm Mike Maneki. I'm the mayor of the village of Alden. We're about to embark upon a 2 to 3 year project to overhaul this facility, which was built in 1984. At that time it was state of the art, but after 32 years the equipment has exceeded its useful life and it's time to upgrade. There are two parts to the project. One is the sewer collection system, which is the pipes that run down the streets and bring all of the waste to this facility. The important part of that is we're going to seal up leaks so that groundwater doesn't get mixed with the sewer system. You may have seen some people around the village in the last week or two putting smoke into the sewers. They're trying to find the leaks. Once they identify the leaks, they'll use some TV camera work and actually find them and determine what has to be done to seal them up. But that'll take place over the next 2 to 3 years. This project will start this fall. You saw the RBCs, the rotating biological contactors. Those will be the first things to be replaced. They're also the most expensive at about $500,000 a piece. The total cost of the project is estimated at $6.8 million, which is a pretty big shot of money for a small community like ours. We're hoping to get some grants to offset that, and it looks like we'll qualify for 0% interest loans. But at any rate, when we're done, the buildings will remain the same, but all the equipment will be overhauled and upgraded. Dan pretty much explained the workings of the plant. I hope you understand. Yeah. He gave you a pretty, because there's a lot going on in the plant, so. But you got to see from the start to the finish.
Special thanks to Dan Slusa and Mayor Mike Maneki giving us an update about this upgrade. This is Margaret Tan, signing off.